Yeah, good morning, Professor. On behalf of my team, we are pleased to present our midterm report on our project, which is titled the Global Energy Consumption Trends and Forecasting. So this project, we are working under the Department of Research and Innovation. So our own program is Big Data Analytics. So today we are going to be walking you through what we have been able to do so far and the insights we have been able to generate from the EDA, the exploratory data analysis, the machine learning models we have been able to develop, and our upcoming steps. My name is Olorotimi Olulano. I'm the project manager. So I might have my other colleagues all here, Tosin Shonoke. I have Tolulokwe Adewumi and Toluwalokwe here also. So our client, which is the Department of Research and Innovation, we have a specific focus to achieve with them, which is the energy sustainability and predictive analysis. So, and our mission is to generate the data-driven insights, which informs decision making to government parastatals, energy consumption companies or companies rather, and maybe researchers just like ourselves. Our projects, we are supporting our clients, which is the Department of Research and Innovation. We are supporting the goal by analyzing the historical energy data and the consumption trends. And we also want to we are developing forecasting models to project for future energy demands. And the work is intended to guide strategic policymakers, and their resource planning, especially in this phase of climate change that we are, the global warming, and also how each countries or maybe each continent transitions, globally into this, how the transition. So for our project objectives and research. So I'll be going through the objective first. So we for this project, we want to analyze the past and the present energy consumption. So the data and develop accurate predictive models to forecast for the future demands. So we have like 5 key research questions that we are working on. The number one is the historical trends in the global energy consumption. The second one is the factors that influences the factor that influence energy demands and how they have changed over time, and also the projected energy consumption trends, at least for the next 20 years, and how the global shift to renewable energy, are is being done, and how we can reduce the fossil fuel, dependency, especially for the carbon source. And also the last one, which is to provide the most effective visualization techniques, for communicating our findings. So these are the research questions. And for the scope that we have our scope is actually to ensure that we stay focused. So we'll be responsible for the full data pipeline. We acquire this data on OWID, and we clean the data, we process the energy data that we have, and also we have applied statistical and the machine learning techniques for the trends analysis and the forecasting. And in the future, we are going to be building for the interactive dashboard in order to visualize the energy trends, and also finally we are going to be developing the policy recommendation, based on whatever we are able to achieve at the end of the day. And for the scope that we have, so within the project timeline that we have, so my colleague Tosin is going to be walking you through the SharePoint that we have. Thank you.
Thank you, Timmy. Now we have to go to the SharePoint site to show the SharePoint. So for the global energy consumption trend dashboard, can we see the dashboard? So now this is the dashboard. It has the project summary, just as Timmy has gone through. And then we have the profile of the team members and brief information about them. So can we go to the MRP high-level task? This is the high-level task list. We have the Gantt charts up here, and down we are at the machine learning model. We have completed the data set identification, data cleaning, processing, the EDA, and we're still on the model selection and training. Can we go to the timesheets? Yeah, so this is a timesheet, and then it shows the title, deliverables, the project phase that we are at right now, and the budgeted hours, as well as the team member that is responsible for each task. The minutes of the meeting. Most recent meeting, our last meeting was done last week, Thursday. And yeah, so this is the minutes of the meeting. We talked about the implementation of the required points that the professor recommended, and then we made adjustments to all his recommendations. So now we'll be going into we'll be going into our Google Colab to show where we started the data cleaning, data pre-processing, and what was done there. Thank you.
Thank you. This is our notebook for all our analysis. So we are done with cleaning our data sets, and we've already made some charts, as you can see from our PowerPoints. At this stage where we've also completed feature engineering and created some charts to compare key insights against different countries and continents. We created charts to compare fossil and renewable energy between China and India, Germany, France, Canada, US. And we also created a chart to show the top 10 countries per capital consumption. We also created um, a chart to show the different kinds of energy sources that were consumed by the top countries and also the continents. So to confirm this, I'll go over to my notebook, and as we can see, this is the section for data cleaning and our analysis, which we have completed already. This is some of the info we have on our data sets, different columns, country, year, population, and so on, and energy sources. This is a brief description of how the data set looks like, the counts, mean, standard deviation, and so on. And DF the column shows our column names. We also handled missing values because when we got our data set, we had a lot of empty rows with no values. So that is what this block is doing here. We are removing rows with less than 70% empty columns. We're also fixing data types of those columns. For example, we are setting our year column as an integer. We are setting our country column as a string, ISO code as a string, and we are handling outliers like the GDP and transforming them into log variables. And printing out our implemented changes, you can see we have no null values in any of our columns, which means our data cleaning was successful. So moving over to some of the charts we created. We created a chart like grouping year by fossil and renewable consumption. From most of our data started from meaningful data started from 1960 over to 2020. We created another chart that says average global share of renewable energy over time. And the next one is on top 10 energy consuming countries in 2023. And as we can see, we have China, US, and India leading charge. We also created fossil versus renewable energy consumption in those said countries. So we're comparing the two major types of energy used in the top three countries. And as we can see, renewable energy is what most of these countries are using. So for the next one, we're comparing energy consumption by continents. Um, so we have two charts, one on fossil fuel consumption over time by continents and one for renewable energy consumption over time by continents also. So we also created a little bit of other charts that compared top three continents, as we can see here. We created one that compares China and India. China is leading the race. We also created one for Germany and France, as we can see, and also for Canada and US. So based on our last meeting, the professor asked us to compare the different kinds of energy sources that were actually being consumed by those top consumers. So we've been able to achieve that, which is this block of code over here. And this is the chart, the stacked column chart we were able to derive from the data. So we have the coal consumption, oil, gas, solar, wind, hydro, and biofuel. We also did the same analysis based on continents. So we created a continent map that grouped each of the top countries into their different continents and also specified energy sources as a list. So basically what we did for the country charts, we also just did it also for continents. So, and finally, we are at the model selection. So we've decided to go with predicting renewable energy share as our model. So the goal is to estimate how much of a country's energy comes from renewable sources and also identify which countries are transitioning faster to clean energy. We have decided to build a regression model to predict the renewable energy share based on the country's economic indicators and the energy consumed by such countries. Why this model is useful? It's going to help us identify which countries are transitioning faster to clean energy. So we've created new columns for our pre-processing and feature engineering that's going to help us with our model. We've created a GDP per capita, our fossil per capita, energy per capita. So we're actually thinking of adding more, but this is going to help us with our model. So as from next week, we'll start working on training our model and also creating test cases for our model. So I'll pass it on to Tolu for our conclusion.
Thank you, Tolu. In order to wrap this up, we had challenges and we had proposed solutions for them. We had missing data and we applied interpolation to smoothing data. We had inconsistency in the country names and we used the ISO codes to standardize it. The instructor also instructed that we added additional data. So we implemented that by enhancing the data set. So for upcoming activities, the stage will focus on generating and visualizing the final predictions for the model, evaluation, interpreting, and drawing insights. Our project cost overview tool was $100 per hour for each total of hours that we had there. And the current recommendations would be to focus policy and investment planning on countries lagging in the renewables. We would also use forecasting to anticipate future fossil fuel reliance hotspots. We also intend to incorporate low carbon share metrics and promote dashboards for real-time monitoring and adjustment. So the project from there continues to advance smoothly with major milestones in data preparation and cleaning. And hopefully we are going to successfully completed the exploratory analysis. Thank you very much.